So we're looking at this book, Descartes' Method, The Formation of the Subject of Science, by Tarek Dika. The book draws, I think, a really fascinating parallel between Descartes' method and the Aristotelian concept of phronesis, practical wisdom.
Right, and Dika really argues that Descartes' method, it's not this fixed procedure, but it's more of a habitus. Like Aristotelian phronesis, it's something that is acquired, a skill.
So instead of this static recipe that we have to follow step by step, it's more of a dynamic skill that you hone through practice. This idea of the method as habitus. Dika spends a lot of time arguing against this idea of it just being a bunch of techniques.
Yeah, he's going through all these texts, like, super carefully, and he's basically showing that it's not just a set of rules you apply, but it's more fundamental than that.
It's ingrained.
Yeah, ingrained. It's a disposition, a way of thinking that you develop. Dika highlights that Descartes viewed science as more than just a collection of facts, and he actually defines it in a letter to Hoagland as, quote, the skill to solve every problem. So that cultivating the skill is essential for uncovering new knowledge.
And that really resonates with the modern emphasis on problem-solving skills.
It does.
It seems like Descartes was centuries ahead in recognizing how important they are. So to kind of put this into context, historically, Dika goes into the scholastic debates surrounding the unity of scientific knowledge. And we have these thinkers like Aquinas, Scotus, Occam, and Suarez, all wrestling with the nature of scientific habitus and if it can unify different areas of study.
Right, and they're all disagreeing about this, about the nature and the unity of scientific knowledge.
Yeah, it sounds like a really lively intellectual landscape.
Yeah.
What were some of the fault lines in this debate?
Well, Aquinas proposed, a gradient ontology. He thought that a scientific habitus could kind of ascend in complexity, unifying knowledge gradually.
Okay.
But Occam had like a more pluralistic model where he thought there were distinct habitus for different disciplines.
Okay.
So you have these different approaches to, can there be one habitus for all the sciences? Can each science have its own habitus? It was a very complex debate that reached an impasse. There was no clear rule to define the unity of a science.
And then Descartes comes along and, according to Dika, revolutionizes this entire debate.
He does.
So how does Descartes transform this conversation?
Well, Descartes proposes a single unifying habitus that's applicable to all scientific objects.
Wow.
He calls this unifying habitus, which you can achieve through practicing his method, sapientia.
Okay.
Yeah.
So kind of like a master key to unlock all scientific understanding. That's a powerful concept.
It is.
And to understand this master key a little bit better, we need to look at the three operations that are the heart of Descartes' method: intuition, deduction, and enumeration.
Right. And Dika's really careful to say these aren't sequential steps, but they're interconnected processes. They all work together.
So instead of this linear process, it's more of a dynamic interplay between these different operations.
Exactly. So,
Yeah.
for example, enumeration, which is the meticulous listing and organization of a problem's elements, it actually sets the stage for both intuition and deduction. So, by breaking down these complex issues, enumeration makes them amenable to those intuitive insights and logical deductions.
It seems like even with the unifying habitus, structured thinking is still really essential for Descartes.
Oh, absolutely. And this structure is further enhanced by Descartes' theory of cognitive faculties, particularly the role of imagination in comprehending material things. And this is where Descartes diverges from kind of the common scholastic view, which emphasized sensory perception as the foundation for intuitive cognition.
Okay.
So he really emphasizes the intellect's grasp of clear and distinct ideas.
So it's not passive observation, it's active mental engagement that really fuels understanding.
And to kind of facilitate this engagement, he introduces these simple natures as foundational elements of knowledge.
Can you give me some examples of these simple natures and how do they function as building blocks of knowledge?
Well, think of concepts like shape, extension, and motion. These are simple natures because they are cognitively indivisible and they possess a univocal meaning across contexts. So shape refers to the outline of an object, extension to its spatial dimensions, and motion to its change in position. So by combining and relating these simple natures, we construct complex ideas.
So like atoms forming molecules, these simple natures are combined to create a richer understanding.
And by grasping the relationships between these fundamental elements, we can then unravel complex problems. And Descartes makes a distinction between perfectly and imperfectly understood problems based on our understanding of the criteria for the solutions and the basis for deducing them and how they're connected.
So there's a hierarchy of problems, some more readily solvable than others.
Indeed.
Okay.
Perfectly understood problems, they lend themselves to solutions by reducing them to relations between measurable magnitudes, and this is where mathematics comes in. This is kind of the area where Descartes' method really shines.
And I'm really curious to learn how Descartes applies this method to the abstract realm of mathematics. What role does picturability play in this application?
Well, Dika goes into this in great detail, and Descartes advocates for representing mathematical problems visually as these bare figures that are perceivable through the imagination,
Okay.
which allows for this intuitive grasp and manipulation of abstract mathematical concepts.
Okay.
He even gives geometric interpretations of arithmetical operations, like addition, subtraction, multiplication, and division.
So even in this abstract world of mathematics, Descartes is championing visualization as a tool for understanding.
Precisely. By translating equations into geometric representations, he makes them more tangible, more readily manipulated. And again, this highlights that interconnected nature of intuition, deduction, and imagination in his method.
It seems like we've just scratched the surface of Descartes' really revolutionary approach, so I'm eager to delve deeper into how this method tackles the kind of messier world of natural philosophy.
Indeed, that's where we'll turn our attention next. The application of Descartes' method to these imperfectly understood problems really unveils its true versatility and power.
We left off discussing how Descartes applied his method to perfectly understood problems, like in mathematics. But now, let's look at how this method addresses these imperfectly understood problems, those encountered in natural philosophy.
Yes, and in natural philosophy, problems often resist being reduced to simple and intuitable principles. So they need a different approach.
So what does Descartes propose for these more complex phenomena? How does his method adapt to that challenge?
Dika illustrates this with the example of the anaclastic lens. It's a lens that focuses light to a single point.
Okay.
And Descartes wanted to design this lens using his method. So he starts by breaking down this complex problem.
So it seems that decomposing the problem is a recurring theme in Descartes' approach. How does he go about kind of deconstructing this challenge of the anaclastic lens?
He reduces it to the behavior of light in different mediums. So he looks at the angles at which light refracts or bends as it passes from one substance to another.
Okay.
And so through a combination of observation, experimentation, and reasoning based on simple natures like motion and expansion, Descartes is able to deduce the law of refraction,
Wow.
which mathematically describes how light bends when it transitions between mediums.
So even in this really complex scenario, Descartes is using his understanding of these simple natures and their relationships to kind of tackle this problem.
And by understanding how these foundational elements interact, he's able to predict the behavior of light and ultimately design the anaclastic lens.
This example is really quite beautiful, how it highlights how Descartes' method bridges those abstract principles and practical applications.
It does. It does. And it's really remarkable that he achieves this without the advanced mathematical tools we have today.
Right.
This really speaks to the power and the ingenuity of his method.
And this emphasis on picturability, this ability to visualize these scientific principles, I think that resonates so strongly with modern learning techniques.
It does. The use of visual aids and representations, it's really a testament to how relevant Descartes' approach is. Even today, it seems, he recognized the power of visual thinking centuries ago.
Dika makes the argument that Descartes' method continues to shape his work even after rules. It influences later works like Discourse on Method and Principles of Philosophy.
Yes, the imprint of his method is evident throughout Descartes' intellectual journey, even his understanding of the human body. It's defined more by its functional organization than its material quantity. It reflects the method's influence.
So this wasn't just a phase in Descartes' development. This was really a fundamental way of thinking that kind of permeated his work.
Indeed, yes, his later writings reveal the lasting impact of his method. And Dika delves into this fascinating discussion around Descartes' unfinished work, Rules. And, there's debate surrounding when he stopped working on it and whether he intended to complete it.
Does this unfinished nature detract from the work's significance at all? Does it diminish its value?
Not at all, not at all. Dika argues that the incompleteness of Rules actually provides valuable insights into the development of Descartes' thought. It's like a window into his evolving ideas about method and knowledge.
It's kind of like we're peeking behind the curtain of Descartes' intellectual workshop.
Precisely, yeah. It allows us to trace the trajectory of his thinking, to see how he refined his ideas. And rules actually contains clues that foreshadow themes that he explores in his later works.
Can you elaborate on some of these foreshadowed themes? What glimpses do we get in rules into kind of Descartes' future thought?
One example is the tension between his advocacy for a universal method and his recognition that different fields might require their own specific techniques. And we see this in his discussions of mathematics and natural philosophy, which kind of hints at the need for adaptability within a unified framework.
So this one-size-fits-all approach has its limitations
Yeah.
even within Descartes' framework. He acknowledges that need for flexibility.
He does, it seems. Even with this unifying habitus, Descartes recognizes that different problems need different tools. And he doesn't advocate for rigid adherence, but for intelligent application.
This adds like another layer of complexity to Descartes' method. It highlights the role of judgment and discernment in employing it.
And this is where the comparison to phronesis, or practical wisdom, becomes really relevant. Because phronesis isn't just about following rules, it's about knowing when and how to apply them and adapting them to the specific demands of the situation at hand.
So it seems that for Descartes, sapientia, like phronesis, is more than just mastering the techniques. It requires wisdom in applying them. It requires the sensitivity to context and this ability to adapt.
Precisely. And this nuanced understanding of Descartes' method, it elevates it from a set of procedures to a very sophisticated approach to knowledge and problem solving.
And this emphasis on adaptability also highlights the active role of the mind in Descartes' framework. The imagination isn't just a passive faculty, but an active engine for generating these new ideas and exploring possibilities.
Yes, the concept of picturability extends beyond simply visualizing existing knowledge. It's about using the imagination to discover the unknown. And, we see this especially in his mathematical work, where he advocates for representing problems geometrically as bare figures, allowing for intuitive manipulation and exploration.
So he's suggesting that even the most abstract concepts can benefit from a visual, almost tactile approach.
And this speaks to a fundamental principle in Descartes' method, this dynamic interplay between intuition, deduction, and imagination. And these aren't, discrete steps, but interwoven faculties that collaborate in generating knowledge.
It sounds like this really tightly choreographed dance between all these different cognitive faculties, each playing this really vital role in this pursuit of understanding.
Dika emphasizes this interplay bridges the abstract world of ideas with the concrete realm of experience.
Okay.
It provides a pathway from thought to application.
And this brings us back to this idea of simple natures as the building blocks of knowledge. They function as a kind of a bridge between the mind and the world. They allow for this common language of understanding.
Yes, they're the foundational elements upon which complex ideas are built. And by grasping their relationships, we can start to understand the intricacies of the natural world. We move beyond mere observation and classification towards a deeper understanding of the principles that govern its behavior.
So Descartes' method, it isn't just describing what we see, but explaining why things are the way they are.
And this focus on explanation, on uncovering the underlying causes and principles, distinguishes Descartes' method as a truly scientific approach. It's about moving beyond surface-level observations and delving into the why behind the what.
But even with this emphasis on clarity and structure, does Descartes' method have limitations? Does it apply equally well to all domains of knowledge?
Well, that's a great question. Dika does address some potential limitations. One criticism, even during Descartes' time, was that his emphasis on clear and distinct ideas might be too restrictive.
So you're saying that the complexity of the world might resist this neat categorization into simple natures and their relations, that there might be aspects of reality that kind of defy this approach.
Right. Some argued that, the nuances of experience might not always fit into the rigid framework of Descartes' method.
This raises interesting questions about the method's applicability to areas like ethics or aesthetics.
Right.
Can simple natures adequately capture the complexities of human values and artistic expression?
It's a point worth pondering. While Descartes believed that his method could be applied universally, his focus remained primarily on mathematics and natural philosophy. So the extent to which his method can effectively address ethical and aesthetic questions remains an open avenue for further exploration.
So even with these potential limitations, Descartes' method still offers this incredibly powerful framework for understanding the world, particularly in those realms of mathematics and natural philosophy.
Absolutely. And its enduring legacy lies not just in those specific applications, but in the way it shaped a way of thinking, this mental discipline that really transcends individual disciplines. And, centuries later, we're still grappling with its implications and exploring its potential.
Dika's exploration is this really valuable guide for navigating the intricacies of Descartes' thought, revealing its historical context, its core principles, and its potential both as a unifying framework and a catalyst for future inquiry.
Indeed, it is. It invites us to kind of reconsider how we approach knowledge and to recognize that interplay of intuition, deduction, and imagination in shaping our understanding, and to appreciate the power of a method that seeks clarity and connection in this world of complexity.
And on that note, I think we've reached a good point to pause our deep dive into Descartes' method. We've explored its nuances, we've looked at its potential limitations, and we've discussed its broader implications.
In part 3, we'll conclude our exploration by examining the lasting legacy of Descartes' method and its relevance for us today.
Welcome back to our deep dive into Descartes' method. We spent quite a bit of time with it now, exploring its historical context, its core components, and we even grappled with some of its potential limitations. But now I want to shift our focus to its enduring legacy. I mean, we've seen how Descartes' method shaped his own work, how it revolutionized mathematics and natural philosophy. But how far does its reach extend? Is its influence confined to those fields, or does it have a broader impact?
That's a great question, and I think Dika would argue that Descartes' influence goes way beyond those specific domains where he actually applied the method. So while Descartes himself primarily focused on mathematics and natural philosophy, his emphasis on structured thinking, on the clarity of thought, and that really interesting dynamic interplay between intuition, deduction, and imagination, it's resonated across various disciplines.
So we're talking about a way of thinking, a mental framework that really transcends disciplinary boundaries.
Think about the scientific method as we understand it today. Systematic observation, experimentation, hypothesis testing, all of these elements, they carry the mark of Descartes' approach. He gave us a blueprint for how we approach knowledge and inquiry. He offered us a framework for asking questions, for seeking answers, that is still so relevant even centuries later.
It seems like Descartes provided not just a method, but a mindset for approaching the world. And this emphasis on breaking down those really complex problems into simpler, more manageable components. That's a hallmark of analytical thinking, which is a skill that's so valuable in so many different fields.
The ability to deconstruct a problem, to analyze its parts, that's at the heart of effective problem solving. And this analytical approach, this real commitment to clarity and precision, I think, have had a huge influence on fields like logic and philosophy and even computer science.
So Descartes' legacy isn't just about the specific scientific discoveries he made, but about this fundamental shift in how we think, how we approach knowledge, and how we conduct inquiry.
Absolutely. It's about cultivating this habit of mind that looks for clarity, that embraces complexity, and that uses the power of imagination. And this goes right back to Dika's central thesis, the idea that Descartes' method is this cultivated cognitive habit, much like phronesis, that practical wisdom. It's not just a rigid set of rules to be mechanically applied, it's more of a way of being in the world. It's an orientation towards knowledge and inquiry that influences every aspect of how we think and act.
That brings us back to picturability, that idea we were discussing earlier. And this idea, too, has had a lasting impact, especially on how we learn and how we share knowledge with one another.
Absolutely. The power of visualization, of making complex ideas more understandable by using visual representations, it's undeniable. Think about the rise of infographics, data visualizations, even our reliance on metaphors and analogies just to try to explain those really abstract concepts. Descartes understood this power of visual thinking so long ago, it's amazing.
So in a way, Descartes' method gives us a recipe, not just for understanding the world, but for creating new ways of seeing it, for making the complex a bit more comprehensible and the abstract more tangible.
That's a great point. The method is both analytical and generative. It helps us break down the world into its basic parts and then put it back together in ways that help us understand it better.
It's this legacy that keeps shaping how we think and learn and explore everything around us. And Dika's book is this wonderful invitation to go back to Descartes' ideas, to appreciate the time and place they came from, and to think about how they're still relevant for us today.
Right. The book challenges us to develop that scientific habitus, to embrace the interplay of intuition, deduction, and imagination, and to approach knowledge and inquiry with a sense of rigor, but also with a bit of creativity.
I think that's a perfect note to end our deep dive into Descartes' method. I hope you, our listeners, found this exploration as thought-provoking as we have.
It's been a real pleasure discussing these ideas with you.
Thank you for joining us. And until next time, keep exploring, keep questioning, and keep cultivating that spirit of inquiry.